The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
Let's go over that mechanism so we can better understand that process. So this reaction, the reaction of an acid chloride with an acid to form an anhydride, begins again with a nucleophilic addition process. So what happens in this case is that our acid will actually add to or attack Okay, I'm actually just going to draw the acid out in a different color just so you can see what's happening at every juncture, at every single stage of the reaction. So that's going to be our generic acid, and as per usual, I am just using generic versions of these molecules because I want you to focus on the chemistry, the reactivity of what is happening. So what happens in this case is that we have our acid chloride, and we have our acid. The first step will be a nucleophilic addition step, in which the acid is just going to add right there, okay, to the carbonyl carbon. The double bond, that pi bond, is going to break, resulting in the formation of an intermediate that looks something like this. Negative charge on that oxygen atom right now. There we have our chloride ion still attached, and now the acid has just added or attached itself to the entire structure, and so we have something that looks like that. Okay, perfect. Now what happens next is that we will have an elimination step. So we began with a nucleophilic addition step, a nucleophilic attack, and in the second step of the reaction, we will be dealing with an elimination step. So this intermediate that we have right here will then collapse to eliminate the chloride ion, and that looks something like this. So a pair of electrons will come down from that oxygen to restore the carbonyl group, and that chlorine atom will exit or leave with this pair of electrons right here, resulting in the formation of yet another intermediate that looks something like this. Okay, one in which the carbonyl group has been restored, and we now have a compound that looks something like this. Okay, so what happens next is that we will have a proton transfer, a deprotonation step, which again is affected by the chloride ion, comes along and then removes or abstracts that proton right there. That pair of electrons moves to that oxygen, resulting in the formation of our final product that looks something like this. Just going to quickly draw that out. So you see, using the different colors allows you to track these different atoms so you can see what comes from where. And that is pretty much our anhydride. So it's a very basic reaction, it's a very basic process. It begins with a nucleophilic attack, a nucleophilic addition step, to form an intermediate that then collapses to restore the carbonyl group and eliminate the chloride ion in that elimination step. What happens in the final step is that we have a deprotonation reaction, a deprotonation step that abstracts a proton from that oxygen right here to form our final anhydride product.